Okay, so this section is section 1.6, integrals involving exponential and logarithmic functions. So, some things to realize, remembering from Calculus 1 that the derivative of e to the x is e to the x. So that makes the integral of e to the x just e to the x plus c. And then similarly, we know that the derivative of a to the x is just a to the x natural log of a, where a is some constant, like this could be for 2 to the x or 3 to the x or something like that. So then the integral of a to the x dx would just be a to the x over natural log of a. And the reason for that would be because if you think about taking the derivative of this is just a constant, right? So then this would just be a to the x times natural log of a, which would cancel out, right? So this is what that integral would look like, right? So they go through an example here of finding an antiderivative of the exponential function e to the negative x. So you can do this with substitution. And if you make u negative x, then du is negative 1 dx. And so you can change this integral into negative the integral of e to the u du. Well, the integral of e to the u du is just e to the u plus c. And then you have the negative outside. So it's negative e to the u plus c. And then change the u back to negative x, and you have negative e to the negative x plus c. Now, I don't think you probably need to do substitution to do this. If you think about it, if I were to integrate e to the negative x, it had to come from e to the negative x, right? And then the derivative of e to the negative x would be negative e to the negative x by the chain rule. So I'm just off by a negative sign, right? And so I just need to put a negative in there to fix that. All right, I think you'll see this one would also work with substitution. This is really just another section on substitution, right? And so this one, very similar, example 1.38, you can do this because you can do substitution. And if you make u the thing on the inside, 1 plus e to the x, then the derivative of that is e to the x. That matches what's on the outside. So you can do this with the u substitution again, where you just make u the thing on the inside, and you end up integrating just the square root of u, and then switching things back. Right? Okay. The other thing that we want to look at here is integrals involving logarithmic functions. And so we know that the derivative of the natural log of x is 1 over x. So the integral of x to the negative 1 is the natural log of the absolute value of x. You don't really know the sign here. That's why you have to do absolute value, but that's how that works. And then this one is a little weird. You may not have known this. We'll actually figure this out. But the integral of natural log of x is x natural log of x minus x plus c. You can just take that as a fact for right now. As a formula that you can have. We will kind of prove that one later. But you can take that as a formula that you can use. And then very similarly for log base a of x, it turns out to be pretty much the same thing, except you have to divide by a natural log of a, because when you take the derivative of log base a of x, it spits out a natural log of a. So that is, again, how that works. So if I wanted to do something like find the antiderivative of 3 over x minus 10, well, this is going to be a log because it's of the form something over x, right? Now it's shifted a little bit, so what you're going to do then is make u x minus 10, right? You can pull the 3 out, make u equal to x minus 10, and then this becomes just 3 integral du over u, because the derivative of x minus 10 is just 1 dx, right? So it matches perfectly. That's 3 natural log absolute value of u plus c, and that's 3 natural log x minus 10 plus c, right? So that's kind of how that works. All right. I think I will just leave that here. You can look at the rest of the examples, but I think that is enough to get you started and a little reminder of how those integrals work.